Hi everyone, and welcome back to the channel. Today, we're diving into a fundamental concept in JavaScript, the difference between primitive and reference types. Understanding this difference is crucial for writing clean, bug-free code. In JavaScript, we have two main ways data is stored: primitives, which live in the call stack, and reference types, which live in the heap. Primitives are basic data types like numbers, strings, booleans, undefined, null, symbols, and big int. Reference types include arrays, objects, and functions. Let's start with primitive types. They're straightforward. The variable holds the actual value. Here's an example using numbers. Const a equals 10. We'll create another variable, b. Now let b equals a and reassign b to be 20. Let's console log both variables to see the result. What happened here? A remained 10 and B became 20. This demonstrates a key behavior of primitives. When you assign one primitive variable to another, you're creating a copy of the value. Changing one doesn't affect the other. And we can see in the console number A 10 and number B 20. The variables are independent. Let's take a closer look at the call stack and see what's happening here. Think of the call stack like a table. It has a column for the variable name, its memory address, and the actual value stored at that address. So for const a equal 10, a points to an address, let's say 0x1a, where the value 10 is stored. When we say let b equals a, b initially also points to 0x1a. However, when we reassign b with b equals 20, b now points to a new address, say 0x1b, where the value 20 is stored. A remains unaffected, still pointing to 0x1a with the value 10. This helps prevent unexpected side effects in your code. Now let's talk about reference types. Here, the variable doesn't store the object directly. It stores a reference or pointer to the object's location in the heap. We'll create an object const object, name John, age 28. Let's make a copy. Const object copy equals object. Now if we modify the name property in object copy.name equals Alice, and then log both objects, console.log original object object, console.log copied object copy. You'll see that both the original object and the copy have the name Alice. That's because they are both pointing to the same object in the heap memory. So what's going on in the heap? The heap is where larger, more complex data structures are stored. Our object variable, in the call stack, points to an address in the heap, say 0x1d, where the actual object data resides. Now when we create object copy is equal to object copy also points to the same address, 0x1d. This means they're both referencing the same object in memory. When you modify a property of object copy, you're modifying the original object as well. There is no copying of the object when you assign it to another variable. This is where bugs can creep in. If you're not careful, modifying a copy can unintentionally change the original, leading to hard-to-track issues. To avoid this, there are several techniques like spread operator or using the object.assign method to create an actual copy of the object in the heap. We'll look at these in another video. I hope this clears up the distinction between primitive and reference types in JavaScript. Understanding how data is stored and manipulated is fundamental to writing robust and efficient code. Thanks for watching, and I'll see you in the next one.